Hello and welcome back. It's been a while, but we're here and we're about to do some standard deviation. So we've got to calculate the standard deviation for each of the following data sets correct to 2 decimal places. Let's not forget about that. So to calculate the standard deviation, one of the first things we need is the mean. And to get the mean, we will need to work out the total, or n, for all of these values here. Let me just change the thickness of the pen. Oh, that's much better. Oh, that's lovely. Alrighty. So n is just going to be the total of all of these frequencies here. So we just need to add them all up. And if you add them all up, you will get 121. Next up, we need to work out the total of all of our scores. So to do that really easily, we know that there's 15 65s. So this could have been a list of numbers, 65, 65, 65, 65, etc., until we've got 15 of them. So what we can do is work out this column over here, f times x. And that's just multiplying the score by the number of times it happens. And that'll tell you, 65 times 15. If you grab your calculator, that's just 975. And that's what 15 scores of 65 would add up to. And we just want to do that for the rest of these values. So 66 times 15 is 990. 67 times 16 is 1072. 68 times 17 is 1156. 69 times 16 is 1104. 70 times 15, that's 1050. Oh, let's make that a bit clearer. 71 times 15 is 1065. And 72 times 12 is 864. And if we work out the total of all of these scores, we will get 8,276. So now that we know the total of all the scores, and we know the total number of scores, which is 121, we can work out our mean. Now there's a few ways that you could write mean. It could be written as x bar, or it could be written as mu, which is a Greek letter. So just keep an eye out for either of those notations going forward. We can work out the mean now, which is just 8,276 over 121. And if we do that, we'll get the mean to be 68.39669, etc. Remember, we only need to go up to 2 decimal places for our answer. So we don't want to round yet. At the very end is when we want to round. So let's try and be more accurate than 2 decimal places. Now that we've got f of x, part of the formula for standard deviation is, well, the entire formula. I'll just write it over here. Standard deviation is equal to the square root of sigma x minus x bar squared all over n. That might look super scary, but we're going to break down every single part of it. So the next bit that we want to do is just work out, actually, what color should I use? Green. I just want to work out this x minus x bar, or x minus the mean part. So I'll just make another column to add onto my table, x minus x bar. And that is exactly what it is for the first row. So x is 65. Our mean was 68.396. I'll just go to 4 decimal places. That's accurate enough if we want to round to 2 decimal places by the end. And this will equal negative 3.3967. And we can do that calculation for every score. So my first score was 65. So x minus x bar, 65 minus 68.3967. And that gives me a negative 3.3967. And we can do this for the rest of our scores. So for this one, this would give us negative 2.3967. For 67, that would give us negative 1.3967. And for 68, that would give us negative 0.3967. You might have noticed a little bit of a pattern, but don't get lazy. 69 minus 68.3967 will not give us what you think. It'll be 0.6033 because we just hit that point around 0. So just be careful, make sure you're not skipping any steps. And then 70 minus our mean is 1.6033. You might see a pattern happening here, and it'll just continue. Oops, not a 7. Let me go back. That'll be a 3.6033. So this column here that we just did represents the inside portion of our bracket. It's just a bunch of scores, and we're finding the difference between the score and the mean. And now we're going to square it. So this squared here. So we can make a new column, x minus x bar squared. And we're just squaring this result here. So this is what we're squaring. So if we put that in our calculator, we'll get something like this, 11.5375, etc. Round it if you need to. Write as many decimal places as you need to. That depends on what the question asks of you, or maybe what your teacher has specified to you. Maybe you've got to do 3 decimal places or 4. That's up to you guys. Anyway, if we finish off the rest of these, we'll get something like 5.744, and that will keep going. 1.9507, that'll keep going. 0.1573, 0.3639, 2.5705, 6.7771, and 12.9837. And that is the difference between the score and the mean squared. But we need another column of work because this result, let's use red, this result happens 15 times because there's 15 scores of 65. So that means this result will happen 15 times. So we need to multiply each of these by f, our frequency. So we'll need one more column, f times x minus x bar squared. And if we do that, we'll get 173 point something, 86 something, 31 something, 2.6 something, 5.8 something, 38.5 something, 101 point something, and 155 something. Now we've got the difference between the score and the mean squared multiplied by the frequency. It feels like a lot to take in, but if you're happy with, what color should I use? Orange? If you're happy with this, Why do we do this part here? Because you're finding out all of the scores. You know 65 happens 15 times, so you're just multiplying that together. And of course, all the scores, if you add them all up, is 8,000, etc. That's a very similar concept with why we're doing this. We're multiplying whatever result we got by f, our frequency, because it happens 15 times. So that's why we're doing this column here. If you wanted to, you could write 11.5 15 times, but I would much prefer to just multiply it by 15, and that's my result. Now, I'm going to keep with orange. Good color choice, me. And then we can work out this portion here, the sum or sigma of all of these values. So we just need to add them all up. So just down here, just underneath here, the sum of all of these, if you add it all up, is 594.9587, rounded to 4 decimal places. Now, finally, we're on the home stretch. We're almost there. So our standard deviation is equal to the square root of the sum of all of these things, which we've just worked out is this number down here. This isn't a very scary number, so we just write that in. 594.9587, and we divide it by n. And where does n come from? Let's use blue. This little n here is just from here. It's just 121. So all you're doing is dividing two numbers and then doing the square root of it. And if you put this in your calculator, you will get 2.217, etc. But remember, what was this point up here? 2 decimal places. So that'll be 2.22. And that'll be the standard deviation for this data. And this is all done by hand. If you've got a calculator with you, you can put this into a table, do one variable analysis where X is list 1 is your score, for example, and list 2 is your frequency, and your calculator will spit out the standard deviation for you. Now this standard deviation is for the population, and that means you're looking at everything in a group. This question, it has no context. It is an abstract question, so we've done the standard deviation for a population. Your teacher might specify to you for these, you're only doing a sample standard deviation, and the formula is slightly different. But anyway, that's all the time we've got today. Thanks for coming along, and I'll see you next time.